All right, guys, this is a great one. We're going to be finding the area of regular polygons. We're going to figure out how to break them up so that we can get the area of any polygon that we're asked to get the area for. There's some words that we need to know before we get started. One of the new words is called the apothem. This is the apothem. And what the apothem is if you start in the center of the polygon, if you hit the midpoint at a right angle, you have what's called an apothem. It is the shortest possible distance from the center to the side. Because this particular polygon is a hexagon, I could draw a total of 6 apothems. And at all 6 of these places, it would be perpendicular at the midpoint. So that's called an apothem of a polygon. The other big new thing is called the radius. Now, you've heard of this with regards to a circle, but a polygon has a radius as well. Again, starting from the center, the radius is the longest distance to the side. It goes to the corner. And since there are 6 corners, I could draw 6 radii. Radii is the plural of radius. So we break it up, and I know my drawings aren't great, but like this would break up the polygon. So you need to know what an apothem is. You need to know what a radius is. Now, if we're looking at this, what we just did is we broke this polygon into lots of little right triangles, and that's going to be the key to getting the area of a polygon. Is we are going to focus on this right triangle every time. And that right triangle is made up of 3 things: the apothem, the radius, and half of a side. We're going to learn several right triangles. You really have to get these down. There's going to be lots of right triangles. You have to know where they go and what they do, even if you're not provided with a picture. If you notice later on in this worksheet, we lose the pictures. So you need to know what they do, where they go, even without a picture. You need to be able to visualize this. And that's the key, because if I can get the area of this triangle, how many of them do we have? Well, on a hexagon, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 2 per side. So like on a pentagon, we're going to have 10 of them. 5 sides, 2 per side. Okay. And the angle at the top we're going to call theta. That's this angle here. Well, what do you think we're going to do to get that angle? Well, picture a circle around the center point here. If there's a circle there, that's 360 degrees. Theta is going to equal 360 divided by, well, on a hexagon, there'd be 12 of them, but there's always 2 times the number of sides. If it's a pentagon, there'd be 10. If it's a 20gon, there'd be 40. So it's 360 divided by 2 times the number of sides. That's how we get the angle at the top. So let's do this actual problem. So keep all of that in mind as we move forward to do the actual question. This says, find the area of a regular hexagon that has side lengths of 18. So it's a hexagon. All we need is this right triangle. Remember where it comes from. If the side length is 18, we know that half the side is 9. The other thing we need is the height. So in order to find area, you need base and height. Well, I don't have the height, but I can get this angle at the top. I know that the angle at the top for this question is going to be 360 divided by 12, which makes it clock in at 30 degrees. Now, I know you're thinking 30, 60, 90s. Woo! They're not all going to be 30, 60, 90s. That's for hexagons and triangles only. So this just follows our 30, 60, 90 rules. So this would be 9 root 3. So how do I get the area of the entire shape? Well, I would do 1/2 times the base times the height. That's the area of this one triangle. But how many triangles would it take to fill in a hexagon? It would take 12 triangles to fill in the hexagon. I also want us to practice doing mental math. So if I was doing this problem, what do we actually have here? We have 9, 9, 12, root 3, and a 2 on bottom. Let's practice simplifying without a calculator. What would be a good first move here? Well, I would do the 12 divided by 2 and make that 6. From there, we got a couple of choices. You could do 81 times 6 or 54 times 9. They're about the same difficulty. I'm going to do 54 times 9. I think that might be a little bit easier. That would be 450, right? That's 50 times 9 plus 4 times 9. That's 450 plus 36. That's going to be 486. Don't forget your root 3. Just to make sure that I'm doing it right, I'm going to go ahead and type it in. 9 times 9 times 12 divided by 2 is in fact 486. Don't forget your root 3. Most questions will ask you to round. If they ask you to round, then you type it in and you round it. But this is the exact answer. All right, we're going to do more. We're going to go really fast through the rest of them. So I talked through that one slow. We're going to speed up. On this one, we know the apothem. The apothem is this piece, and it is 12 inches. We're going to draw this triangle. First step, every problem is draw the triangle. The piece we have is the apothem. It's a pentagon, so there would be 10 of these. So we do 360 divided by 20. 360 divided by 20 would give us 18 degrees at the top. And I still need that number to get area. So we would do the tangent of 18 would equal opposite over adjacent. So x equals 12 times the tangent of 18. So the base is 12 tan 18. So the area is 1/2 times the base, 12 tan 18, times the height, which is 12. How many of them are there? Well, it's a pentagon, so there would be 10 of these. Remember, there's 2 per side. So this is the situation. You can think of this as being 12 times 10 times tan 18 all over 2. So what would be a good way to do this? I might do 12 times 12 is 144, divided by 2 is 72, times 10 is 720. Coming up with good ways to do this in your head is very important to being really good at math. So there's our answer, 720 tan 18. I'm going to do the next one. Honestly, guys, the picture just gets in the way. Every single problem, what are you doing? You're drawing a right triangle. And that right triangle, you need to be able to picture where it goes, but like you don't need to actually draw the big shape out. It's a decagon, so how many of these would there be? Deca means 10. That means we're going to have 20 of our shape. Oh, no. I messed up on the last one. This is incorrect. Hopefully you're still watching. I messed up. This would actually be 360 divided by 10. What am I doing? What am I doing? This would be 36. So let's fix it everywhere we see it. I apologize. It's 36 the whole time. Yep. I done goofed. There we go. There we go. Sorry about that. There's not 20 triangles on this one. There's 10. Yikes. I wouldn't have even realized it if I wasn't about to get the same number. So I don't know why I did 20. Who knows? But I messed up. Okay. But over here, it is actually 20. It's 360 divided by 20. This one is 18. That is the right number. This time it's the radius that is 10. The radius is 10. We want to find the area, so we need to know the apothem, and I'll call this x. We need to know the base and the height. So we're going to do 2 different trigs. We're going to solve for x. That would be the sine of 18 equals opposite over hypotenuse. So x equals 10 sine 18. We're going to solve for the apothem. The apothem would be cosine 18 equals the apothem over 10. So the apothem equals 10 cosine 18. Now we can do trig, now we can do the area formula. So that would be 1/2, the base would be 10 sine 18, times the height, 10 cosine 18. So 1/2 times base times height, times how many are there? On a decagon, there are 20 of them. Oh, did I mess that up too? Oh no, I got the 10 right there. That's crazy. Okay. So there would be 20 of them on a decagon. So this would be like 10 times 20. And we're dividing by 2, right? Just, we'll put this in later, but that's what we're doing. Practice doing this in your head. Well, 20 divided by 2 is just another 10, so that would be 1,000. 1,000, and we have a sine 18 and a cosine 18. So that's your final answer. You will be just typing this. You will be typing these into a calculator eventually. But right now, I want you practicing as much as you can, getting the exact values. All right. Here, see, now the picture's just gone, but we can still do the work. 9 sides. We draw our right triangle. We're going to do 360 divided by 18. That's going to give us 20 degrees. If there's 9 sides, there would be 18 of these triangles. The apothem is 5. I'm going to call this x. So when I'm solving for x, that would be the tangent of 20 equals x over 5. So x equals 5 tan 20. So the area would be 1/2 times the base times the height. And because it's a nonagon, there would be 18 of them. So we have 5 times 18. Well, 5 times 5 is 25. I would probably do 18 divided by 2. So 18 divided by 2 would be 9. So 9 times 25 would be 100, 225. And don't forget there's a tan 20. Practice doing it without a calculator. One more on the page here. Again, right triangle. N is 15. So we're going to do 360 divided by 30. That's going to be 12 degrees. The radius is 7. So I need to find both of these sides. Okay. So this takes 2 trigs. Solving for x, that would be the sine of 12 equals x over 7. So x equals 7 sine 12. And then solving for the apothem, that would be the cosine of 12 equals the apothem over 7. So the apothem is 7 cosine 12. So find the area. Area equals 1/2 times the base. The base would be x. Times the height would be a. And then since there's 15 sides, there would be 30 of these triangles. So half of 30 would make this 15. 7 times 7 is 49. So we have 49 times 15. So 49 times 10 would be 490. Half of 490 would be what? 200 plus 45 be 245. So 490, 690, 715. And then we have sine 12 times the cosine of 12. I'm going to go ahead and type that in just to make sure I didn't get that wrong. I did get it wrong. It's 735. What did I mess up? Well, this is a rough video. Sorry, guys. What did I get wrong? 49 times 10 is 490. Plus half of that. Did I get that number wrong? What's half of 490? Be 245? Oh, I added 225. I added 225. That's where I messed up. It's 245, I think. I don't know. It's 735. We got it. All right, guys. That's regular polygons, though. Every time you do the same steps, you draw the right triangle, you get the angle at the top, you plug in whichever side you have, you do trig to get the base and the height, and then you get the area of that one triangle, and you multiply it by all the triangles. We got this.